Good morning. My name is Bobby Bassett. I'm the training manager for the Gates Corporation, and this morning we'll spend just a few minutes and talk about loss of tension in the accessory belt drive system. We'll learn about the accessory belt drive system, or what the ABDS is. We'll learn how loss of tension affects the accessory belt drive system. We'll learn what a slipping belt does to the system itself, and there's a lot of stuff that's happening to the system that I think you'll agree will impact your job. Now, you as technicians or future technicians, let me ask you this. If you do your job right and correct, who pays you? Well, the customer does, doesn't it? Don't they? Well, if you have to do it again and it's a comeback, then who pays you the second time? And I can assure you your labor rate is not as good as your customer. And I think you'll agree as we walk through this that this one item that we're talking about today is creating comeback after comeback after comeback, but we just really didn't understand what was creating the problem for us. So you can help yourself by helping your customer understand that certain things in the system today have worked together. And we'll spend just a few minutes and talk about understanding the impact of loss of tension in the accessory belt drive system. It's so important today to understand this because, after all, what does a belt do? It powers everything in the system. And that's why it's important to understand today. You know, it's really not your daddy's V-belt anymore. It's not your daddy's car, because what happens is, in years past, we used to teach that V-belt should never bottom out in the pulley, right? Well, if we bottom out in the pulley, it creates heat, it creates noise, and it can also, it does not allow an airspace where water or air can pass up under it. Today, serpentine belts cannot bottom out. So if they can't bottom out, what can they do? And that's the question, because we're teaching old school, where today it's new school, because a serpentine belt today cannot bottom out, but it can stop and ride on top of the pulley. And that's important to understand, because I love to begin my conversations this way. Have you ever heard a belt squeal? And if you have, did you know it's not a belt problem? There is absolutely nothing wrong with the belt. The belt squealing is a symptom of another problem that you have in the system. But the problem that we have today is that with the techs, or especially at the counter, we don't have the knowledge we need to help understand what's really happening in the system. So if you have a belt that squealed and you installed a belt on your customer's car and it squealed, 2 days later they're back, you take it back to the parts store and the counter guy goes, "Oh, I'm sorry, let me give you a new one." 2 days later the customer's back with the same squeal. It's not a belt problem. It's a systems-related issue, and that's what we have to look for as we begin to diagnose a problem. You know, we have customers that tell us after they've just struggled with a belt that squeals over and over and over again, they say, "You know, we don't make belts like they used to." You're absolutely right. We don't. We make them much better now than we ever did before, because by the time our belt squealing is not a systems belt problem, it's a systems issue, and we have to start wrapping belt noise around loss of tension. If when a customer brings a belt in and if it's squealing, we can't just assume it's a belt problem. We have to go one step further to determine what the noise is, and by using the spray bottle test. Now, if you go to the Tool for School site, there's a video up there we just produced that talks about the spray bottle test, and the way to use this. Now, we have to be careful, because we learned this technique from a technician by the name of Nubby, because the system is running. And so we've got fans, the motor's running, the belt's running, so everything's operational. So if we stick our fingers in the wrong place or get our clothes in there, then we can be in a lot of trouble. However, with the system running, you want to take a spray bottle filled with water and water only. And the reason you want water is that it acts as a lubrication. Now, you never want to use any type of petroleum-based product. We don't want to use carburetor cleaner. We don't want to use WD-40. We don't want to use that yellow chalk that's on a tire, because all of that is detrimental to the belt. If you ever spray, it's important, just water only. So if we spray the application with water and the noise gets louder, that means it's tension related. It's just like I ran through a puddle of water, and If it's tension related, then I need to replace the tensioner, don't I? If it's a chirp, 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 and I spray it and the chirping goes away, it's an alignment issue. Now, these systems will only tolerate 1 degree of misalignment. For each degree over that, we start compounding 30 degrees of heat. You know, we begin to see that belts weren't being replaced. The technicians weren't replacing the belt. And the reason is the material in the belt has changed, and we'll talk about that in just a minute. And the danger with this is the customer comes in, you replace, it's a high-mileage vehicle, you replace the alternator, and you look at the belt and you go, oh, that looks okay. You install it 2 days later, they're back with a no-charge situation or a belt is squealing. The commonality is today, because of the wear patterns of the belt and the material it's made out of, we're replacing the belt and not installing a new one or replacing the tensioner. So the failure continues over and over and over again. The commonality is we're reusing the same old belt and the same old tensioner. I like to show this picture. This picture, to give you some knowledge, comes from a very large box provider that we deal with, a big parts store chain. And this is all the failed products, quote, what we call perceived failed products that you return. This is when you installed a belt on the customer's car, it squealed, you take it back to the jobber, and the counter guy goes, I'm sorry, let me give you a new one. Now, you think about this. For you, this represents a comeback. For the jobber, it represents a warranty. And that warranty has to go somewhere, and it ends up in a holding warehouse, or it ends up back at the manufacturer where they test. Now, I want you to remember that one thought, that it can end up back at the manufacturer. Now, I will tell you this. There were over $10,000 worth of belts, micro V belts or serpentine belts, in this pile. And on the back of every one of these belts, there's a card that somebody writes the problem for. Now, the interesting thing is the warehouse manager came back and asked while I was sorting through all these belts, how many of these are failed because of workmanship and material? The sad reality is I went through every one of them. Not a one was failed because of workmanship and material. In fact, I've been doing this since 1978, and in the life that I've been doing this, I've only seen 5 actual failed belts from workmanship or material. These belts were failed caused by something else in the system. The interesting thing was on the back of every card, 99% of the statements written on the back, because they had failed, the statement read one way, and that was the belt makes some type of noise. And if the belt makes some types of noise, it's due to loss of tension in the system, and it's not a belt issue. But the counter person and the technician keeps throwing a belt after belt after belt trying to solve the problem when it's not a belt problem to begin with. It's tension related, and that's what we're here to talk about today. What does a belt do? The belt only job is to transfer the power from the crank to all of these accessories, and it does so by wedging force, and that is the wedging force of the belt down into the grooves of the pulley. That creates friction. Now, if you look at a new belt, it will have fuzzy stuff on it, and that's what grabs that pulley. If you ever see a belt that's glazed and shiny, that means it's lost all its gripping ability, and it's just sliding through the pulley. So what we're doing now, a belt only it transfers the power or torque from the crank to all of the accessories, and it does so by the wedging force that creates friction. And that friction or wedging force is created by the tension placed on it by the tensioner. If either one of these products are failed, it allows that belt to slip. And if the belt's slipping through the pulley, it can only do one thing, and that's to make noise. So as we begin to understand, as the belt slips now, it's creating a tremendous amount of heat. And that heat goes right into the bearings of the accessories. Now, water boils at, what, 212? What does grease boil at? Our engineers tell us that it begins to really drop out at around 320 degrees, and so that's extremely hot. Now, once that grease drops out, we have bearings that are what? Dry? They're running dry, and it's creating failure. Now, as this belt begins to slip, it's making noise. It's also, all the accessories now are operating at a diminished output. So now I have an alternator that's not charging correctly. I've got an air conditioner that's not cooling correctly, or a water pump that's not pushing water through the system. So now, if you look on the left, all of this begins to happen as a belt begins to slip. Who would have thought also as a belt begins to slip, it can wear material out on the pulley itself. So now I have a pulley that's totally worn out, but it's very difficult to see. I can provide a tool to show you when a belt's worn out. I don't have a tool yet to show you how to tell if a pulley is worn out. Before I leave this picture, I want to show you two things. On this, and everybody should have received a poster by now, which looks similar to this. On the left, this is a micro V system or a serpentine system. How do I know that? It has a tensioner. On the left, this is a stretch belt. How do I know that? When you look at a stretch belt or a stretch fit belt, there's no adjustment on it. So how do I get that off? You look at it, you just simply cut it off. The stretch belt is for another presentation. We won't have time to talk about that today, but we do have time to talk about loss of tension in the accessory belt drive system and how it's creating tremendous problems for all the technicians all across the world. In fact, this is truly an industry-changing message that was introduced around 2010. The systems today must have PAT, pulleys, alignment, and tension. We have to have pulleys that are free and clear of dirt, grease, and grime. If it's got stuff in the pulley, let's get it out. We highly recommend 100% visually inspecting all the pulleys and cleaning them with alcohol-based brake cleaner. Soap and water works great too. Nothing petroleum-based. If you don't clean these pulleys and you've had a head gasket leak and all the pulleys are soaked with oil, as soon as you install the new belt and turn the key, the failure starts all over again. They're coming back. And that's why it's so important today. The nice thing about it, if you find a failed pulley in the system, you get to replace it, and if you get to replace it, you make more money. It's that simple. So begin to inspect the systems, and I think you'll get to eliminate a lot of the comebacks that you will see or have seen or will see in the future. This is a high amperage alternator, and you'll see it begins to wear out. The only way you'll see this is under an electron microscope. This is what the pulley should like. It should be straight up and down. Now, as a belt begins to slip, it begins to wear away material, and I'll address that here in just a minute. The systems today must have the correct alignment. These systems can only tolerate 1 degree of misalignment. For each degree over that, we start compounding 30 degrees of heat. Now, where does heat go? Right into the bearings. In this picture, you're looking at two different types of misalignment. This is called parallel misalignment, and that's when two pulleys are offset. The one on the right is called angular misalignment, and that's when two pulleys, they can be offset, but they're also turned from one another. Each one of these develop a tremendous amount of heat. Remember, 1 degree of misalignment is all you can see, or all they can tolerate, and you can't see that with the naked eye. You need to use some type of laser alignment tool to help bring this back into alignment. The systems must have the correct tension. If we don't have the correct tension, then the belt can only do one thing, and that is to slip. What's happening in the industry today, we used to teach cracks. Look for cracks. If a belt cracked more on one rib now, if we had more than 3 cracks in a 3-inch section on one rib, that meant the belt had used up 80% of its material, and it was soon to fail. But what you have to remember is this is a neoprene belt. That's old school. Around 1995, we began to change the material to EPDM, and the EPDM was such that it can wear it. Oops, I just had something pop up. It wears totally different than what a neoprene belt does. In fact, the belt on the right has over 100,000 miles. 100,000 miles. The neoprene has about 65,000 miles. But it's important to understand because of the wear characteristic. What am I checking for now? And we're looking for belt wear. What happens as a belt begins to slide through the pulley, it begins to lose material. So it's no longer gripping the pulley. It can't grip the pulley to create the friction that it needs. All it can do is slide through. But once it begins to slide through, a serpentine belt can only go so far down in the pulley. It stops, and then it's simply riding on top of the pulley. And that's when the noise and the squealing begins. So that's why if you hear a belt that's making noise, basically the belt's worn out and there's loss of tension, and that can come from two places. It can come from the belt that's worn. Just 5% material loss will let that belt slip. Or a tensioner that's not operating correctly, because one other thing you need to understand is because material has changed, we used to get 2 neoprene belt replacements to 1 tensioner replacement, because the tensioner was built to go, run 100,000 miles, somewhere in there. On average, some will go, can run well over 100,000 miles, and it all depends on duty cycle, what's happening in the system. The reality is this: today, when you replace a belt and leave the tensioner on or don't check that tensioner, you're asking that tensioner to run another 100,000 miles. It can't do it. It's probably already met its life cycle and needs to be replaced. We need to pay more attention to the tensioner, because loss of tension either through belt wear or a failing tensioner is what's creating major issues for the industry today, and constant comebacks for you, the technician, which is costing you money. These are the 5 most common belt failures that we see, and let me preface this by saying this doesn't happen to just Gates belts. This happens to all belts. So really, we're speaking for the industry here. This is what's happening in the industry. If you see glazed and shiny, it means that the belt's been slipping. If the belt's been slipping, there's not enough tension, and if there's not enough tension, we need to replace the tensioner. It's that simple, really. Make sure you visually inspect and change or clean all those pulleys. Side abrasion. Side abrasion, and this is what I call Groundhog Day. This comes back over and over and over, and because we don't have the knowledge that it points to one thing, and that's the tensioner. A tensioner, as it begins to wear, and I'll explain that in just a minute, there's a component inside the tensioner that wears out that forces that belt to track uphill, and it ends up looking like it's side abrasion. The commonality is it's all on one side. It can be a slight scruffing to just massive rips, just ripped out of the belt. But it's side abrasion, and it points right back to the tensioner. And typically what happens from our end, and in that big pile of belts that you saw, probably a good third of them were side abraded belts. And the unfortunate reality was the counterperson did not have enough knowledge, nor did the technician to understand it's the tensioner that's causing this issue in most cases because of misalignment. Pilling. Anytime you see a belt that's pilling, if you look down on the bottom of a belt inside the groove, you may see bright, shiny things. These aren't the little specks now. These will be small little things that are piled up. As a belt begins to slip, it piles up rubber. You'll especially see this in the less expensive retail type belts. But what will happen is as it begins to slip, it rolls that rubber up and deposits it in the top. Now I've got noise, vibration. It also may be an indication that I've got a worn pulley because it's allowing that belt to run back and forth on the pulley itself. Of course, in years past, we looked for cracks. Today, we're looking for belt wear, and I'll show that to you. This is what, again, we're looking for is belt wear using the same information. Here is the neoprene belt versus well, I got a tire up here, and I hadn't replaced that one yet, but that should be the ABDS belt. The material begins to shear away, and what we do is we take our small belt wear tool, we insert it into the belt. Now, I have to caution you, because we got a call the other day on this. With the engine off, please. You can put that belt wear tool on your finger, and you can stick it into the belt with the engine off. And if you can feel the belt over the top of it, it means, the little tool sticking up, it means we have fairly decent wear left in the belt. If it disappears in the groove, it means that all the material has sheared away and the belt's no longer gripping the pulley, it's simply riding on top. Now, can a failed belt still turn the pulleys? Oh, it can, but it can't do it effectively as the system begins to load up. Our engineers tell us that each accessory scavenge about 5 horsepower from the system, the water pump around 1. So once we begin to turn everything on, there's a tremendous load, especially with these high amperage alternators today. There's my ABDS belt. So you can see 100,000 miles versus the neoprene. Now both of these can be worn and you can check it with the belt wear tool. The EPDM belt will crack, but the cracks are much smaller, so they're a little more difficult to see. And when you see an EPDM belt crack, it is absolutely time to get it off, because failure is fairly imminent on it. It will fail fairly quickly from that point forward. The interesting thing is, we begin to do a research, we begin to get the alternator people involved in this message as well. And you'll see there's quite a few alternator folks, vendors, that are including this information as well. We've worked with a lot of the OEs. In fact, you'll see a note from Chrysler here in just a minute. But in years past, we knew that 20% of the alternators were returned. These are, remember that big pile of belts? These are the alternators that you installed. A week later, they're not charging. You take them back to the jobber. They send them back to the factory. When they get back to the factory, they found that they either had bad diodes, bad batteries, or in the vast majority of the cases, it was a slipping belt that was creating the no-charge situation. Now, here's the interesting thing, is that we had and this was a couple years, 2010 is when we had this. Now today, with these vendors that we're working with, anywhere from 55 to 70% of the accessories, or specifically the alternator that's returned back to the factory, when they test them, there's absolutely nothing wrong with them other than the belt was not able to transfer the power. Now, what does that tell us? That tells us that we're not paying attention to, because of the material and the belt has changed, we think it's okay when it's totally worn out, that we're not paying attention to the tensioner, which is the key component. Personally, I'd rather see you change the tensioner than replace the belt, because it's the tensioner, after all, that maintains the correct amount of tension on the belt at all times. But remember this now, the life cycle of both are almost the same, and that's why we highly recommend one-for-one replacement today. We had one large box customer that we deal with, and they just took an effort. They did a test, and they recommended a belt every time they sold an alternator. Believe it or not, through their test period, they were able to eliminate up to 47 alternator returns back to an average of one store a year. And what that means is, or back to the store, that is huge when you look at the thousands of stores that they have. And these are the alternators that you buy, you install, they're not charging for whatever reason, and they go back. Just simply by installing a belt with the alternator eliminated the comeback. Now, the return to you was a comeback and lost profits because you had to do it twice. For the jobber, it was a warranty. And in all cases, nobody wins when there's a comeback or there's a warranty. So why is this not being looked after? This is Chrysler. As we begin to reach out to some of our partners, Chrysler certainly provided this information to us. The number one false code, let me go back. A slipping belt today can create a false code to be created because there's so many sensors in the system. Anything that confuses that the crank sensor can create a false code. And a slipping belt is one of them. This is information from Chrysler, and basically what it talks about, this is the engine misfire, is the number one false code created on a Chrysler product by a slipping belt. That's huge. A failed tensioner can create a knock sensor code. You can have some of the AC clutches today have sensors in them, and when they feel the clutch slip or the belt slip, it turns the clutch off. Now they bring it into your shop, and you put it on the machine, and you see maybe the AC is marginal, so you recommend, oh, well, we need a new compressor. You install 3 compressors, and this actually happened down the street where they replaced the first compressor. The customer's back 2 days later. They replaced the second compressor. The customer's back 2 days later, and the third day they're back again. Not only did they lose a customer, but what they found out was the commonality was there was nothing wrong with the compressor. It was the sensor in the clutch that was feeling the belt slip and simply turning the clutch off so it would not generate heat that would go right through the bearings, creating premature bearing failure. Unfortunately, they lost the customer because they charged him for that original replacement anyway. They had to work with their jobber to replace the other one. So you'll see this information is from Chrysler. It notes that anything that affects the speed of the crankshaft can cause a misfire, DTC. So, and these are some of the notes. So the information is validated. The thing is, we're not teaching this information. None of this information is being taught in diagnostic classes. And why is it being missed? Because, now these are the two sensors that we're specifically talking about here. And this is the flow chart. I was in a class, and yes, I still go to school. I was in a class at a NACAC conference, by the way, and sat in on one of the vendors that sell the scanner. And he began his conversation this way. You know, we need to teach our techs today on how not to believe what the scanner's telling them. And I went, wow, what a profound statement, because what happens is we follow the flow down, and it can be something as simple as a belt that's creating a lot of havoc in the system. We just don't know what it is. In fact, after one of these classes, I had two technicians come up, and he said, we had a car in the shop last week all day long. And he said it sat there all day long with a knock sensor, kept tripping it. He said we couldn't get it to turn off. Someone came by and said, why don't you replace the belt and tensioner? And guess what went away? If you get Motor Magazine, in June or July, Sam Bell wrote a really nice article on just this information. Go find it if you can. We provided a lot of the information to him, and he sent back, as soon as it was published, he sent us a really nice email from a technician that had a phantom code 300 show up on one of his customers' car. He couldn't get turned off. So using that information, he said, why, with the engine running, and he had to be very careful because the engine was running, he said, with him and his helper, said, I was able to put a little more tension on that tensioner, and then guess what went off? The code went away. The light went off, simply because it was the tensioner that was not placing enough tension on the belt to begin with. Why is this being missed? When you look at the troubleshooting, almost in no cases, then this is one of few for a Chevrolet Cobalt where it even mentions replace the belt. In most cases, it never even talks about. It does not talk about the belt. Almost in all cases, it never mentions replace the tensioner. The tensioner is not a hard part. It's a usable product that's made to be used up, whose lifespan is around 100,000 miles. Now, it can go 200,000 miles or more, or it can fail very quickly. It all depends on duty cycle and what's happening in the system at the time. This is a product or a failed tensioner that was provided to me by an installer close to us as I began to gather parts for some of my classes, and he said, don't let this be a $500 mistake. Basically what he did is customer came in and wanted an oil change and wanted their belt replaced because he believed in preventive maintenance. They were going on a trip to Dallas, Texas. He picked the car up at 5:30 on a Friday afternoon. 45 minutes away, guess what came off the car? The belt did. The customer called him. He said, don't worry, I'll send the tow truck. He sent his tow truck. He had to keep his technician there after hours. They had to pay an extra fee to have the dealership, who was the only person at the time that had this part, they had to pay an after-hours fee to have someone go back in the dealership and get the part. And what they found out was that this pulley, polymer pulley, had already failed. They didn't see it, though, because they never inspected the system. He said, we just don't change belts anymore. He said, we inspect and clean the systems, and if we find problems like this, we replace them. And guess what? If you find that and replace that, you make more money. So, and eliminate the comeback that may happen later on. So let's spend just a minute, and we're almost through, but I'd like to spend just a minute and talk about the importance of the tensioner in the system. The tensioner really performs two jobs, and the first job is it maintains the correct amount of tension on the belt at all times, and that's through its complete duty cycle. As things turn on and off, it's maintaining the correct tension on the belt at all times. It also dampens the impulses of the engine. If you've got a six-cylinder engine running at 2,100 RPM, that's a lot of impulses going right through that belt. And the damper inside of the tensioner is what removes that. So knowing that, there's three different failure modes that a tensioner will show you, the technician. The first and most obvious is loss of spring tension. If the belt's beginning to squeal, It's due to loss of tension either from belt wear or from a failing tensioner. So loss of spring tension may be the obvious. Now, how do I check a tensioner? And this is, hopefully you can see this. This is a tensioner. You want to spin cycle it, and that means that with the engine off, with the belt removed, and I've inspected all the pulleys, you want to spin the pulley to see how it feels. Now, if you've got a pulley that's in bad shape, do yourself a favor. Don't just install a new pulley. Remember, if you install a new pulley, now we're asking a brand new pulley that's going to run another 100,000 miles to operate on a tensioner that's probably already met its life cycle. Your customer's coming back at some point. So it's a cheap insurance to go ahead and very inexpensive to go ahead and replace the tensioner at the same time. So we want to spin the pulley to see how it feels, and if it feels good, then we'll assume and clean it and inspect it, it's okay. The next thing we want to do is insert your wrench somewhere, and you want to cycle it 3 times from lock to lock. Now, I'm looking for if there's a ratchiness, if there's a binding, but really I'm looking for side motion this way. A tensioner will cycle 1 billion times in 100,000 miles. So it's got a lot of back and forth motion as accessories turn on and off. So things have to wear. You'll see there's not a lot of stuff inside of a tensioner. So the next failure mode is the pivot bushing. And the pivot bushing, and I'm going to remove this case half here, take the tensioner apart, hopefully you can see this, is, let's get it where you can see, it's a small plastic piece right here. And what that does is it just acts as a bushing that as the tensioner is moving, it's not a bearing, but it acts as a bearing or a bushing. But through 100,000 miles, or 1 billion times in 100,000 miles, it begins to wear. As it begins to wear, then it forces that arm to move this way, which forces that belt to move uphill, and that's where that side abrasion comes from, just like this, up on the far right. If you look on the bottom right, that is a tensioner that created 3 comebacks for a technician. He couldn't see it. It was buried in the engine compartment, and you can see that it began to fail. Someone finally walked by and said, "Why don't you replace that belt and tensioner?" Which he did, and then it took care of the problem. The last thing is called a damper. A damper is simply there to it's one of the key important parts that are inside of a tensioner. This is one of 5 designs, if you can see it, and you're looking at it right in the center bottom of your screen. Let me explain to you the way it works. The damper is there to dampen as each cylinder fires. Again, it's sending a lot of pulses through the system, so it's there to remove that. As I take my case half apart, I look at this, or I teach this as a brake drum. Okay, this is like a brake drum. This is like, if I get it centered, like a brake shoe. So I insert this brake shoe into the brake drum, and that connects to the spring, that connects to the arm. So the harder or the more tension I have on the belt, the harder this brake shoe presses on the inside of that brake drum. If you see that arm begin to hammer like this, then that means it's a failed tensioner. And for the instructors out there, again, I don't want to play this today because a lot of the screens will go black. But if you go to the Tool for School site, you'll see there's a failed tensioner video. If you look on the left, that's a failed tensioner. The interesting thing is most techs today think that's okay. We see those all the time, and it's not. You've got a failed tensioner in Mrs. Smith's vehicle that will create a comeback for you. As you look at this running, you'll see that the one on the right is also operational. We simply removed the old one, put a new one on, and you'll see how smooth that is. So after this is over, please take a few minutes, go to the Tool for School site and to review the videos. So what we learned today is that the inspection process has changed from cracks to wear because the material has changed from neoprene to EPDM. Just 5% material loss will let that belt slip. And if it begins to slip, it creates noise and heat for the system. The life cycle of the belt and tensioner are almost the same because, remember, in neoprene, in years past with a neoprene belt, we used to get 2 belts to 1 tensioner replacement. Today, it's almost 1 for 1 because both the belt and both the tensioner's life cycle are built at just about the same interval. And that's why it's so important to help your customer understand that when they come in and go, my belt's squealing, it's not a belt problem, it's a systems problem, and it typically begins with loss of tension. I certainly appreciate it. Hopefully we learned something today, and if you have any questions, feel free to, since we don't have mics turned on or enabled, feel free to type them in, or either email me the questions and I'll send the replies back to you. I'll wait just a minute, and anybody has any questions, we'll. If not, thank you very much. Again, this will be archived up on the Tool for School site for later review, and I'll probably have this up there sometime next week. Thank you so much. I see someone's typing something, so I'll wait just a minute. Oh, and if you would, instructors, I would appreciate just a follow-up email to tell me if things worked right and if it was beneficial for you. All right, thanks, Chuck. Thank you so much, guys. If there's no questions, then I certainly appreciate it. And if you happen to have another class, you're more than welcome to join the next session as well. Thank you.